Let's discuss question number 16 from test 2. This is from IC engine, so thermodynamics. The method of determination of indicated power of a multi-cylinder SI engine is by the use of. Okay, so this is basically by Morse test, but I'll just spend some time on explaining what is Morse test. So you have 4-cylinder engines. Okay, it can be SI or CI, but it has to be multi-cylinder. What you do is initial all the cylinders are running, so sum of all the IPs basically will be equal to the brake power produced plus the frictional power when all cylinders are firing and the shaft is running at some speed n. Okay, now I remove one cylinder, so this is basically IP1 plus IP2 plus IP3 plus IP4. This is first statement. Now I cut the fuel supply, or basically in a SI engine, basically it would mean there is no spark, or I don't provide spark, there is no spark or misfire in one, or no spark in, so I cut the electric supply to the spark. There is no spark in one cylinder, so that cylinder will not produce power. The total power will be produced by say second, third and fourth. Okay, and the brake power is again new brake power, so this is BP when all are firing star. This is BP when one, so this is BP, what should I, when one is removed. Okay, plus frictional power. Now frictional power will be same. So here basically what you have to do is you will adjust one requirement. What you have to do is basically you will reduce the load on the cylinder such that it again comes back to the same speed, because now only 3 cylinders are producing power. Power produced is less, so basically the torque that is coming on the shaft, engine shaft, will be less, so this the speed will try to decrease. Now you decrease the load on the brake dynamometer, so finally adjust the speed or maintain the same speed. So when you're maintaining the same speed, the catch is that the frictional power is proportional to speed. So frictional power when all cylinders are firing and when one is removed, the frictional power is same. That is the basic idea. So now when I subtract 1 and 2, I basically get IP1, because this will be subtracted by this. I'll get IP1 as BP star when all are running minus BP when one is removed. Now friction power being same. So just noting down the readings from the brake dynamometer, torque and the tachometer reading speed, I can just calculate brake power, and the difference of the brake power will give me just the indicative brake power IP1. Similarly, I can do the procedure for different cylinders. For SI engine I'll not provide spark for the second cylinder, or basically in CI engine I'll not provide the fuel supply. So the piston will still be moving in that cylinder. Okay, and the idea is to maintain speed constant. That is again by adjusting. So this is, you would have performed this in your laboratory. So you will decrease the load, so speed comes back to the same speed. Okay, so basically the maths is behind these two equations. One when all cylinders are firing, the second equation when one of the cylinders is removed. So that is how. So you have to just write down these, and when you subtract, you will get the indicative power of the cylinder which was not firing. Okay, so this is how. So the Morse, this is basically the Morse test philosophy, and this is how it is done. Answer is A. Thank you.